Okay, good morning, Prof, and then good morning, my classmates. I will try to present my assignment 4, but I only focus on the answers. I did not rewrite the questions, just the answers. Okay, from the questions that the textbooks ask us is, we start from step 1 to step 8. So from step 1, we are asked to specify a model for our 7 independent variables, including 1, which is life expectancy, that makes it 8 variables. But these are the description of the variables. We have our life expectancy as the independent variable. Then all the other variables are the, life expectancy is the dependent variable. The rest are the independent variable. So from this information given, I design our model from equation 5.1. So the expansion of equation 5.1 is what gave us this model right now. We have our yi as the dependent variable, bo as the intercept. The rest of the variables are the explanatory variables. Then I just give a brief explanation of the regression here to know the variable terms. And then we have our variable that makes it econometrics variable as the error term, the random error term. So question 2 asks us to hypothesize the sign of the coefficient. What kind of signs do we expect to have from our different coefficients? So these are the signs that I think we will have from the independent variables. So I believe that methods have a negative relationship to life expectancy. I also believe that uninsured will have a positive correlation with life expectancy. Then smoking is negatively correlated. Obesity also negative. Teen birth is negative. Gun law is positive. Metro is negative. The definition of all this smoking, obesity, and other variables is given in the first table that I displayed. Yes.
So the first one.
Yes.
Median income is negative relationship
To life expectancy.
this your expectation.
Yes.
So means the income higher.
It does not have any, like if the income is higher, it does not justify that you will live longer or not.
Correct.
Yes.
It's not justified.
No.
Then you think that's negative relationship.
Yes.
So income. So by theory, the income is higher. Then the life expectancy will be lower
Yes, for me.
from your point of view.
Yes.
Okay. Then how about the gun law?
The gun law have a positive relationship because if you put in gun protection for children,
Yes.
if the protection is higher, it will have an impact on the life expectancy. It means
Okay.
it will protect the kids and then they are like, let's say for instance what is happening in the US. You can be walking in the street and you can be shot by any person. So that's a short life expectancy, right?
Then how about metro?
Metro have a
Negative relationship.
negative relationship as well.
Means what?
When we look at the definition of metro up here, we said metro is the percentage of what population live in a state I
Yeah.
that live in a metropolitan city area.
So means
so-
the more people live in the metropolitan area,
Yeah.
the longer negative relationship.
Negative relationship.
The less
Yeah.
life
because-
expectancy.
Yes, I believe the metropolitan city is full of pollution. It's full of other
Okay.
issues. Yeah.
Okay. Sure.
Yeah, the air quality in most of the metropolitan cities are not good. So you're breathing in a lot of toxic air and other stuff.
Okay.
If you're living in the countryside, which the environment
Okay.
is green,
Okay.
so you get more clean air than in the metropolitan city. That's
Then
what I
for
believe.
the median income,
Yes,
the richer, the shorter life expectancy.
I think
This
so.
is what you think.
Yeah, because for the richer income earners, once you are rich, sometimes you don't pay attention on your life itself. Like you focus on more on, like for instance, your balanced diet itself, what you eat, what you do. But if you earn less, you are more conscious about certain things that you should do. Like you don't get into alcoholic life and other stuff because you don't have money to afford all that. So you need to definitely rely on what you get and then how you spend it.
Then don't you think some theory also show that the wealthier, the more wealth?
So
company,
this is not concrete to say that the more money you have, you will live shorter. I just based it on the data or on my own analysis.
Okay.
But you can use.
So why don't you do the, just no directions?
Like natural.
That's two-sided test and neutral.
Yeah, it's possible. Some people can test and have a positive correlation.
Okay.
But from
since we are in the class, we do some agreement
Yes.
in the class that one of the variables will be make it two-sided test because we want to do the practice.
Oh.
So here, all of the variables are in one direction only.
Yes.
So you are not able to practice the two-sided test.
Two-sided test now.
Yeah,
I
okay.
just focus on the one-sided test.
Okay, sure.
Yeah.
Okay, go on.
No, somebody raised his hand before.
Huh? Somebody raises hands?
Yes.
Like for instance, in America, the poorer you are, the less you have access to healthy food. For instance, so actually, like the poorer you are, the more you tend to eat unhealthy food and fast food, which leads to obesity and therefore reduces life expectancy.
Yeah, like I said, Professor said that some of the variables will be two-sided tests, but I just based it on one-sided test. Also, in theory, you can have different theories that will explain all these variables in a different way. So my judgment is based on one-sided test.
Yeah, okay.
Yeah, if I do two-sided test, maybe most of the signs will change. But a class before Professor give assignment, I was not around. I just read from the textbook and then I use one-sided test.
Yeah.
I don't understand how the one-sided test would impede on the correlation between median. Like, why the fact that it's only one-sided would make like the income, high income, suddenly make the life expectancy.
Well, basically, I think, okay, from my point of view, median income and also the metropolitan, these two variables are really unclear. So if I were you, I wanted to do this two variable as two-sided test. Okay, I think the rest of them, like uninsured or smoke, obesity, teen birth, is more, for example, uninsured. The more uninsured, the longer life expectation. This is, I don't know, this
Well,
can be
let's-
two-sided too.
So let's look at the definition of uninsured. They said uninsured is the percentage of a population aged.
Without,
Yeah,
without health insurance.
0 to 60. In a state that was without health insurance. Without health insurance.
Without health
Yeah.
insurance,
Yeah,
right?
It means they don't have health insurance. Without health insurance.
Then the longer life, you did a positive relationship means
Yes,
that
yes.
without insurance, the more percentage of uninsured, then
The longer,
the longer life.
they lived, yeah. I believe one reason.
Well, it's kind of maybe I don't know, maybe it's not that clear because this can be both sided too.
Of course, it can be. I agree with you. But my judgment is based on, imagine if you, like we said, from the metropolitan city and then non-metropolitan city. So if you don't have a health insurance and then you lived in an environment that has good air quality, or you don't
Yeah.
rely on junk food, you are totally vegetarian or vegan or something else. So you can see it from that perspective that it is also possible.
Yeah, I think, we can also some other argument for two-sided, for, median income, uninsured, and also metropolitan. I think these three variables, you always can say something in both ways.
Yes.
Yeah, okay. All right. Go on.
Okay, we move on to step 3. Step 3 asks us to do a summary statistic and then to see if there is any outliers, abnormalities in our data. But the perfect way to do that, I think, is very difficult to use e-views unless if you use the percentile in order to check the abnormalities. But what I did is I just look at the probability and then the standard deviation. I look at the probability of the whole data and then the standard deviation, the probability here. You can see that gun law probability is way below 5%, and then our
What is this probability for?
no, I just use the probability to see whether there is whether the data is equally distributed or not.
Equally distributed.
Or not, yes. Also, I look at the standard deviation compared to the mean. All the other variables, their mean.
Excuse me.
Yes.
I think this probability is based on this, right? We didn't learn it in the class yet.
Yeah, it's based on that. I'm just trying to.
This probability is based on these numbers.
Yes. But I use the probability in order to see whether we will have outliers or not. Because the data.
Whether we have outliers or not.
Yes. The question itself asks us to see whether there is any abnormalities in our data or not.
Yeah, okay.
Yes. So if you looked at the data set itself, I mean, the mean for the other independent variables or dependent and independent variables, their mean and standard deviation, and then compare gun loss mean and standard deviation, you can see the difference.
Well, this gun law,
yes.
how do we have the value with gun law?
Which one?
Gun law
Yes.
is a dummy
Yes.
variable. It's
Yes.
0 and
0
1
or
only.
1, yes.
So what does this mean? What does this probability mean? Basically this is it's not for masters levels information. Okay, we didn't learn this yet. Okay, but since Max is going to say something about this one, so by the way, I just say something about it. Okay, so the probability of this one is talking about what kind of information from this probability? Since this is a dummy variable.
Yeah, it's a dummy variable.
So this is not normal distribution.
Yes.
All of the variables is talking about whether the variables are normal distribution or not. Okay? So the higher the probability means what? The higher the probability means what?
The better the distribution.
Is reject or do not reject?
Reject, yes.
Reject. No, do not reject.
Do not reject. If the probability is very low,
this
we
is
reject.
lower means reject the
Reject.
null hypothesis,
Yes.
right? So
From 5%,
normal distribution. So all of them is do not reject it.
Yes.
So they all follow the normal distribution according our classical assumption. One of them is talking about the distribution of the y variables. Okay, so actually this is not normal probability.
Normal, yes.
It's a dummy variable, 0 and 1. So actually this is binomial distribution
Binomial, yes.
instead of normal
Normal
distribution.
distribution.
So we don't see any, actually we don't see this information here.
Yeah.
It's nothing related to.
Now I just try to find out the abnormalities there. So I just think using the probability.
Abnormal.
Yeah.
Well, you are not able to, from this one, to find the abnormal because this is a dummy variable.
Dummy variable, yes. You're right.
Okay? All right.
So our step 4 said we do the estimation for our coefficients.
Okay.
So this is the output of our coefficient estimation. So like we explained before, after running the data, and then our metro, obesity, smoke, thin bath, unsecured, gone low, only 2 of our variables are positively correlated to life expectancy from my output. So the table displays the results. So before we talked about this, we already did a summary of explanation on this from the hypothesis science expectations. Yes. So that's the analysis down here. Our results above shows us that the mentioned variables have a negative relationship, but however, our results give us a positive relationship between unsecure, gone low, to our independent variable, life expectancy. Step 5 asks us to do the hypothesis testing using the t-test statistic. So when we use the t-test statistic, before we get into this table.
Oh, by the way,
Yes.
we have to do this for all the variables using critical t-test and also p-value.
P-value, yes.
Both of all
the,
of them.
I use the table.
But you didn't do this one. You just do this one.
But we have to use all the
All of the variables using critical value and p-value approach. And if it is a two-sided test, we need to do the confidence interval approach.
But from the
Yeah, I know that.
the question.
But last night, there are students asking me, we already said it in the class, right? We do both for all the variables, didn't we?
I was not in class, Prof.
Yeah, sorry about that, okay?
Yeah, I just based everything on the direct questions.
But
asked by
since
the
last
textbook.
night, some students asked me whether we want to do, they clarify
Right.
the question again. So I show on the class line group, say,
I don't open the-
combine step 5 and step 6 for all the variables and doing this,
Again.
all of them.
So instead of using only 4 variables, we have to use all the variables.
Yes.
I
And
just-
p-value approach for all of them.
Oh.
Okay. Well, never mind.
I just based mine on strictly
sure.
on what the question is.
Sure. Oh,
Yeah.
Okay, they say something about this one, okay?
From this table, I guess some of my variables are missing according to Professor because we have to do for all the independent variables, but I just did for 4 independent variables. And using the t-test, so
Well, excuse me. When we do the hypothesis testing, we need to go back to our original model. We don't just use these 4 variables to, we have to do when we do the hypothesis testing, we have to specify our model first,
yes.
right? Then based on the original model and do the hypothesis testing either using critical value approach or p-value approach
P-value
or
approach.
confidence interval approach. It doesn't mean we change the model to the 4 variables or 5 variables on the questions.
Yeah, no, I did not provide the model itself from the original model.
Why?
I just used the original model and I went down straight to the question and just substitute it from the original model.
Let me see so excuse me. This is the one, this is one, you're using y variables and only this 4 variable, only.
Only those, yes.
No, this is not what we want to do the hypothesis testing.
You say we have to use all the independent variables.
Sure, sure.
But the question, like I was not in class, the question just said that hypothesize this.
No. According to the questions
Yeah.
for step
5.
5 and step 6 say hypothesis testing
Yes.
and test the slope coefficient by several variables.
Yes.
It doesn't mean change the model.
Okay.
We do have the model already. For step 1 is to specify the model.
Yes.
So as long as we have that model, we do the hypothesis testing about our
Our original model.
original model.
Okay. I was thinking because if you see step 5.
That's why we have to step 1, step 2, step 3,
Yeah.
by logical thinking. So if you do the hypothesis testing about this new model, what for? What's the reason for this one? What's the reason to specify the model in the very beginning? This doesn't make any sense, right?
Yeah, excluding, like you explained, excluding the other variables, and then without driving this one from the original model.
Yeah, this is the wrong model.
Yes.
Why do you have to do the hypothesis testing based on the wrong model? It's not for step 5 and step 6 doesn't ask you to change the model. It just say that do the hypothesis testing by some portion of
From the
the
model.
independent variable of the original model.
Yes. Instead of I just reduce the original model from here, like I said, I just jumped straight to the question itself, and then what I did is I just use this model. This is the original model that we expand from
Okay.
equation
Yeah,
5.1.
yeah.
So what I did is instead of I rewrite this model and then use the model down, I just substitute the question, what the question asks from us, using smoke and then obesity and then gun law.
Then excuse me. Then
A teenage.
no. Go back to the original model. Output. Okay, do the hypothesis testing using this output. Say something about this one. And what you have done
Yes.
is not correct. This is the correct model. So say something from this output.
Then if I'm to use this output, I need to do hypothesis testing for this independent variable.
Sure. This is the correct one.
Yes, so if I use this, it means I just have to have to use the one-tail test in order to see the hypothesis test for,
Yeah, sure.
for this model.
Okay, so using the p-value approach first to explain all the variables here. Using p-value approach.
Just the p-value approach.
Yeah. Explain p-value approach first. And according to your expectation, right?
From the p-value approach, if you look from this table, since we are using the t-test, one-sided test statistic, so it means our our values here will be divided by 2.
Yeah.
Yeah, we will divide all our values, each value by 2, in order to get for.
Do this all follow your expectation?
Yes, only these 2.
Only these two,
are
right?
positive.
All
yes.
of them are
Negative,
negative and
yes.
follow your expectation.
Yes.
Okay, then say something about this
Yeah.
one.
So for the p-value approach, we are doing a single test. To do the single test, though the hypothesis is not going to show whether our alternative hypothesis is accepted or the null hypothesis is rejected. But if we divide this by 2, since we said our acceptance level is 5%, 95% confidence interval. So
Alpha is 5%.
yeah, 5%.
Yeah,
Yeah.
okay.
So if we divide these things by 2,
Yeah?
if it is below 5%, it means our null hypothesis. If we say our null hypothesis is less than or equal to 0, it means we cannot reject our null
Cannot reject
our
or
null hypothesis.
cannot reject?
The null hypothesis. If we say the null hypothesis is less than or equal to 0,
Less than equal to 0?
yes, or greater than 0, alternative hypothesis greater than 0. So if we divide this by 2, if it is greater than 0, it means our null hypothesis will be rejected. Then we will accept our alternative hypothesis.
So, what's the result?
The result is if we reject our null hypothesis, it means
Which one you reject the null hypothesis? Which variables, which coefficient is rejected?
if we divide this by 2 is more than 0, we will,
We need to compare with alpha level instead of 0.
yes.
Alpha level is 5%.
Yeah, that's what I'm saying.
Compare
If-
with 5% instead of 0.
0, yeah. If we divide this by 2, it will be below 5%.
Huh?
This.
Oh, we don't see the constant.
Okay.
Yeah. Second.
So this one, let me divide it by 2. It will be 0.314 something. So that's
compare
below
with
the alpha level of 5%.
alpha, yeah.
Yes.
So it's,
If it is below 5%,
Uh-huh.
we cannot reject our null hypothesis. Or we have to reject the null hypothesis and
Yeah.
accept the alternative hypothesis. Yes.
yeah, okay. So what's the result for all of it? Based on the probability p-value approach, what's your conclusion? So the first one, net income, reject or not?
Net income, do not reject the null hypothesis.
Reject, do not reject,
Yes, the
okay?
null hypothesis.
Then Metro,
Metro also do not reject the null hypothesis.
huh?
Right. Wait. Or reject the null hypothesis and accept the alternative hypothesis.
And obesity,
The same.
okay? Then smoke,
Yeah, the same too.
okay? Teen birth,
Yeah.
then uninsured,
Uninsured is also the same.
same as what?
The same as we reject it. We do not reject our null hypothesis.
Do not reject it.
Yeah, do not reject the null
Then
hypothesis.
gun law,
Gun law also do not reject the null hypothesis.
do not reject.
Or reject the null hypothesis and accept the alternative hypothesis.
Yeah, okay.
Yeah, yeah.
Then, based on the critical value approach, what's the critical value now? How do we find the critical value for one-sided test? What's the critical value here? We have 51 sample size, right?
Yes.
Then how many variables do we have?
We have
7.
We have 7. It's gonna be n minus k minus 1.
So it's 43.
For 46.
Huh?
Minus
46.
1. Yeah.
51 minus 7
Minus 7
minus 1.
1.
So 43.
43. Yes, 43. Sorry.
So what's the critical value?
That.
Let's check the table, right?
Yes, the T table.
Let's check the T table. Okay, that will be, based on our table, it's close to 40. Then for one-sided test, 5%. So which will be 1.684. 1.684. Let me see what you have for the...
Below. Since I did not use all the
Yeah.
independent variables,
Okay, let me see
I just
what is
used,
the critical value.
Yeah, I just used
1.681.
Yes.
Where did you get this one?
from the T table. But from the T table, I use
From the real T table.
yes.
Yeah. Okay.
Not from
okay.
non-variable. I
Yeah.
use
So it's pretty close to this one.
Yeah,
since
instead
we're-
of the 7 variables,
Yeah,
I just
okay.
use 4 variables.
Yeah, sure,
So
sure.
the 4 variables, 51 minus 4 minus 1, I got
Okay.
46.
Yeah, okay.
So I checked from the table and
Okay.
then it gave me this.
Then use 1.684.
Yes.
Okay, go back to the original. Go back to original output. Then do the hypothesis testing. 1.684, 1.684, and you can follow with the negative sign or positive sign, either one of them. How do you do the hypothesis testing? Using critical value approach.
Let me make reference to this.
Let me see what you have. Okay, you are working with the negative,
Yeah.
but all of the t tables you are using positive. The critical value is wrong.
No, for the 4 variables that I use here, net income is positive and unsecured. Uninsured is positive.
Oh, okay.
Yeah.
Then
Net,
your unsure is positive.
yes, and net income is positive. That's what we work
Positive.
with the positive critical values here.
But why did you say less than? Is this the unsure? No,
No, no, no.
no. So unsure should be the fourth. Beta 4.
Yeah, uninsured is the beta.
Beta 4. Lower, lower. Okay.
It's
Beta
this
4.
one.
Beta 4. Let me see.
No, this is
Beta
our
4.
uninsured.
This is beta 2.
Beta 2, yeah.
And you're using the negative.
Yes. No, from the regression, I think my uninsured is beta 3.
Oh.
Uninsured is beta 2 here from the original model, Prof.
Okay.
Yes. So when we come down here,
You know, the coefficient.
yes,
So uninsured is beta 2.
yes, from my original model.
Your original model.
Yes.
But you say that you're doing positive relationship. But here is negative.
Oh.
What's wrong with that? Uninsured is beta 2.
Yeah.
So you're working with the positive relationship, right?
Hmm.
So the alternative hypothesis should be positive instead of negative.
Less than, yeah, it should be greater than 0.
Something wrong with here. I think you understand what I'm saying
Yeah,
here,
yeah, I
right?
got what you're
This should be positive.
Yeah.
So the
think-
step 1,
No, I think
It's wrong.
the whole issue started when I don't use the whole model here. Instead of using the original regression, I just base it on 4 variables here. If I use the original model here, which is this one, if I use the original model here and then do the hypothesis testing, like you said, to combine step 5 and 6. Yes. If I combine step 5 and 6, that would have been easier to explain. But when I just based it on this, and then
And either
yes.
either you are using just 4 variables.
Oh, yeah.
You are also expect this is positive, right?
positive, yes,
So where is the hypothesis testing for this one here?
it's better
Where
to
is it?
better to down
It's beta 2, but you still put the negative.
negative relation.
So that's wrong,
Wrong, yeah.
right?
Yeah, you are.
That's wrong. Okay, go on to the
Wait.
step 7. Do
7.
overall F test.
This one.
Yeah. Excuse me. Is this how you write down the alternative hypothesis? What is this?
This means we say our HO is equals to the null hypothesis B1 is equals to B2 equals to B3. This is joint hypothesis testing now. We're doing a joint hypothesis test to see.
Have you ever seen alternative hypothesis like this one before?
Yes.
Where?
In one textbook, I think I don't have the soft copy. I used that textbook in quantitative methods.
I don't think so. I never seen this kind of alternative in my life.
I can snap the page and send you after class.
Really?
Yes.
Then that's terrible. Never write this kind of alternative hypothesis here. Never, never,
Yeah,
never.
I did not take this from the textbook that we are using. I use.
No. This is very uniformly state
Yes.
a statement for alternative hypothesis. If you write it something like this one, I don't think any one of them learn hypothesis testing
like this.
before will accept the alternative hypothesis like this one. This is totally wrong.
Why?
What do you mean by this one?
Because this one we are saying our alternative hypothesis B1, B2, B3, B4.
They are not equal, right?
Yes.
And also not equal to zero.
Zero, yes.
Then how about if I have beta 1 equal to beta 2? Does this statement also sustain?
No, the statement does not say, but if we say it's not equal to 0, then we do the test. This will prove that one of our beta is not equal to 0.
Well, this one is just saying there's a one situation, which means all of them are not equal, but also not equal to 0.
Yes.
It doesn't include that maybe I have all of them equal, but just these two not equal.
Equal to 0.
So alternative hypothesis should include every situation besides null hypothesis. So this kind of statements is never correct.
Really?
Really. You can ask
No, I did not
any
ask,
professors.
yeah. No, I took it from the QM textbook because I'm using that textbook.
Show me the textbook.
I will snap the page and send you after class.
Well, this is never write this kind of alternative hypothesis.
Okay.
Never, okay. In the future, never do that. This is wrong.
Okay.
All right?
Yeah.
You know, what we always say is like, at least one of the beta j not equal to 0, j is from 1 to 7.
7, yes.
Or some books will say that all the beta j, there's a different kind of expression, and then look at our books to say null hypothesis is not true.
Yes.
Okay, when we say null hypothesis is not true, this is just only one situation. It doesn't include every situation except null hypothesis. Okay?
All right.
All right. You know, I bet that if you work in your PhD dissertation and you're writing something like this kind of alternative hypothesis, you're going to have trouble.
No, I will not use this.
You know,
I just based it on the textbook theory because I used that textbook. And the textbooks give us this alternative hypothesis testing. So I used this.
I'm not going to scare you. I'm just saying the truth.
I know.
You know, all of you also have this kind of same problems. Never write down the alternative hypothesis for overall F-test like this one. And this is very good example to, for teaching purpose. This is good example for the.
Because what I was thinking from the textbook's explanation, right? We had to base our judgment on the null hypothesis. So our alternative hypothesis, we want to test whether one of them is not.
No, alternative hypothesis is our purpose.
Yes.
So we have to pay attention to the alternative hypothesis instead of the null hypothesis. Alternative hypothesis, this is the key for the hypothesis testing theory.
Yes.
Alternative hypothesis is always the research hypothesis.
Yes, true.
What we mean by research hypothesis is the purpose we wanted to do.
The research.
We wanted to show the evidence, right? So alternative hypothesis is real important. The statement from alternative hypothesis is real important. Okay? Okay, say something about this test. F-test.
From our F-test, we just try to test to see whether our null hypothesis, we said that our B2 to B, our independent variables are non-equal to 0. So we want to test that whether it is true or not. So our F value is 37.8800. But when we look at from the F table, which is 2.23, so we can reject our null hypothesis. Mm-hmm. Yes.
Okay. Can you get it from output to have the p-value?
The p-value, this.
Yeah. I mean, directly from output for F-test.
I think we can, but we have to do some.
Let's go back to the output.
The original output.
The original equation output. Original one. Yeah, okay.
Yes.
Can you get information from here?
Yes, I think we can get information using our, this is SST, SS something. And then our F-test here, and then the F-test that we did down are the same.
Exactly right.
The same, yeah.
Exactly right.
Yeah.
So what you have done, and actually we can get it from the output here.
Yes.
Okay, so you can get the F statistics, you can get the p-values. So just find the critical value for F tables,
Yeah.
then you can compare these numbers. You don't have to do the test like that.
Okay.
Usually the test that is for partial F-test.
Yeah, that's for partial.
For partial F-test instead of the overall hypothesis.
Test.
Overall F-test. Overall test is already here.
But I think even if we do the partial test, it will not make a difference. Will it? If you use the wall test. If
for
you use
partial,
the wall, yeah.
partial F-test is for partial of the variables.
Yes.
Okay? Now we are doing the overall F-test. It's for everything.
All the variables.
But if you want to do just, for example, if you want to do just this, the beginning 5,
Yes.
the beginning 5, then you can use in this one, then go to the wall test or the one you just showed,
Yes.
to do the partial F-test. But still, we have 7 variables. But I just wanted to do the 4 out of them, for example.
Yes.
That's for partial.
Partial,
F-test.
I know.
Yeah, okay. So for the overall F-test, it's just exactly from here.
Yeah.
And what you have done it, since you show all the variables, therefore what you have done is the same as these numbers,
Yes.
okay? All right?
Prof, I think I still need you to throw some light on this because from what I read from that textbook,
Okay, sure.
yeah,
Sure.
I
Just show me, okay? Show me some other time. Show me the alternative hypothesis for me.
after class I will send you.
Yeah,
that.
sure.
Yeah.
Sure. No problem with it.
The final step, right? Step 8.
Well, again, you have to use in the original
Yes.
models. So say something from original model about these 2 variables.
Yeah, but here, this variable here, we reduce it by 3%.
No. Go back to
Go back.
your original one. Say something from your original one. As long as you know how to do it, you can look at just your original models. Yeah, look at this one. Then say something about gun law and smoke.
Okay, from our original model, we start from the coefficient. I believe that smoke is negatively correlated to life expectancy. But question 8 asks us if we reduce smoke by 3%, will it have an impact on life expectancy? Or does that mean that passing a gun law protection can protect the...
Well, the first one is asking us that whether the gun law
gun law protection.
have bigger impact on the life expectancy than
Smoke.
reducing the smoke.
Yes.
Yeah. So what's your answer?
Answer is, I agree with that statement. If gun law protection increases, or if you put high gun law protection, it will have an impact on life expectancy.
So this is your conclusion?
I'm just trying to explain that.
Yeah, okay.
Yeah.
Okay. I think that's it. It's about the time.
All right.
Okay, thank you very much. Okay, let's take a break.
No, I just want to talk about this. It was from the textbook that I told you, from that textbook's perspective.
Okay, show me the
I will snap the page. It's in the door. But when I get to the door, I can snap the page that I got.
sure.